Hello everybody and welcome to Greg's Vintage Workshop, where I'm working to restore history one piece at a time. Tonight we're going to continue on with the 1935 Grunow 1151-11B console radio. When I introduced it in my last video, we got started on one of the can capacitors, and tonight we've got a couple other capacitors that are, one's a big can, one's a small block. And then of course all the tubular capacitors. We're going to work on those, and I also get a new power cord in it, a new dropping resistor in it, and we'll see what else we do from there. But without further ado, let's get started. Okay, so I got the filter condenser can put back in, and now we're getting ready to attack that big 8 microfarad condenser that was right in that spot right there. First remembering this one right here. Bolted in there. So I got it out. We're going to recap it. But I was also going to show you, I also got the actual line filter condensers replaced. That's those in there. Those are making up for this one here. This big one. And the one that was missing beside it, that's what's still a hole right there. So replaced that one and that one, or now that one and that one. Right there, the red lead and the black lead are the condenser can that I just replaced and restuffed. Come up through that hole right there. So now we're getting ready to restuff that one. And I'll show you that. Okay, so I got that open. I split it across the bottom so it wouldn't be seen. I'm going to fit that back together with some Cand-ohm tape on the bottom. Here's what the 8 microfarad condenser looks like came out of it. I believe that was 8 at 475. I could be wrong. It might have been 300. Actually, I take that back. Right here. It's an 8 at 300. So I'm using a 10 to replace it. Same 10 that I used for the filter condensers. These green ones. And I printed a block for it that I can put in there. And it'll go in here. And the leads will be attached and be moved over to the outer edges of that so that they can go in the holes. So let me get those in there. Okay, so there it is, good as new. It turned out pretty good. I'm happy with it. Piece of Cand-ohm tape on the bottom where I slid it, and on this end. And from what's seen, looks just like it did. Let's test it real quick. It was an 8 microfarad at 300. I put a 10 microfarad at 500 in there. And we'll see what we get here. So it's showing 9920 NF, so right at 10 microfarad, and so I think we're good to go. So now we can put that back in. Okay, there it is back in place. The 8 microfarad that I replaced with a 10. Now let me show you that on the schematic over here. So I'll come over here to show you which one I just replaced. It's this 8 electrolytic right here, which basically goes from the plate of the second detector audio tube through this 250 ohm resistor through a tubular cap, and then that's it. And then it's going back over through the output transformer to the output drivers, and that's the one I replaced. So I just got through replacing this 4 microfarad at 25 volt right here, which is between 2 voltage dividers for the second detector AVC 85 tube right there. That one right there. The reason I'm showing you is kind of significant because the size difference. I just had to show it to you. So here it is right here. 4 microfarad at 25 volts. It's interesting the way they mark this. Usually the black end's the negative, which in this case it is, but then on this end, this bigger black end, they got marked as positive. But anyway, let's look at what replaced it. This is where it was, and this is what replaced it. This is a little 4.7 at 50 volts, and the way I did it, I tied it into wiring, but I also shrink wrapped it to it to support it, so it wouldn't be trying to pull the leads out of it. Hopefully you can see that. Okay, so I've just been working myself through this chassis, replacing the waxy caps and any defective out of tolerance resistors. I'm not completely done yet. I still got one underneath this IF can, another one over here, and a couple up here. I also installed a 10 ohm 50 watt dropping resistor here. It should be more than sufficient to cool this down, take my line voltage from 126 down to about 115, which is where this radio lives. And got my UL knot on there and a fuse. So continue on here. Okay, so I've been working my way through all of the tubular waxies capacitors, and as you can see here, I've pretty much got them all in there. I've been changing resistors as they have tested bad. Most of them are within tolerance. A few of them that were way out of tolerance. I had one 68 ohm that was testing out at 120 something ohms, and just things like that. Over here's my little stack. And you can see I got 1, 2, 3, 4, about 5 resistors in there. Okay, now I'm getting ready to tackle this CAN capacitor that actually has 6 capacitors in it. There's 6 wires coming out here. These are all very hard wires, very stiff. But I got to take the CAN out from this side, and I'll show you on the schematic what we're talking about. So here's a schematic of the CAN capacitors. We got 2 005s. We got a 0.5. Actually, we got 3 0.5s and a 0.25. So I'm going to probably use 0.047s for the 05s. Unfortunately, I don't have the anything bigger than 0.05 right now. Close, but bigger. So I'm going to go to 047. I think their tolerances were within 20% anyway, so I think we're fine. Okay, so here's that capacitor can with the 6 caps in it. I'm probably not going to print anything 3D print for this. I think I'm going to mount a terminal strip in there. All of the capacitors terminate the negatives together to ground to the can, and I'm sure there's a ground wire in here probably right where this solder joint is, and probably just mount me a terminal strip around that vicinity there and tie the negatives in and just let that terminal strip sit down inside there. That's kind of my thoughts. I'll bring it back when I get it together and we'll see what it looks like. Well, that's apart now. Much harder than I expected, but I got it. A little bit of blood, sweat, and tears along the way, but we got it. Now we get it cleaned up a little bit and get the new caps ready for it. Okay, so here's iteration 1 out of the printer, and it turned out pretty good, but I want to make a couple changes to it. So I've got iteration 2 printing right now. I've got all of the capacitors attached to the wires, and then I've got them color coded to match the print. And the black wire there is going to be the negative, that although they technically ground to the can itself, I'm going to take them over to a solder point right on the chassis itself via this black wire. That way I know there's no reason that they don't have a good negative to the chassis, because the can is going to be reliant on the threads, and this way I'll just have them right to the chassis and be good. I'm going to put some heat shrink on each of these, and those will be ready to go into iteration 2 of the filler. I know I told you guys I wasn't going to do one of these, I was just going to use a terminal strip, but after looking at it closer I decided the terminal strip would be a little bit more difficult, so this is the way to go. So I'll bring it back. Okay, there they are, all heat shrink done. I used the coil method to attach the capacitors to the wiring, soldered it, and I did find the outside foil on all of them. That's what the markings are on the end. I marked the negative outside foil end on each of them. Okay, so I got my new capacitor holder can printed out, complete. This is version 2. See the holes go completely through. They did on version 1 too, but the slot, I increased the depth of the slot, opened it up to this section right here, and that's where the ground for these are going to go. The negative for these is going to go in like that, tie into the bottoms. Let's put this together and I'll show you what I'm talking about. There's that one. There's that one. That one. That one. And there we go. So the recess I put, the square recess, was so that I can bend these leads down to get them over to where they need to go and let them lay flat like that, so they can all come out the hole right above that cap right there. And then once that's that way, then the whole thing will slide in here like that. I made the legs long enough that they'll reach the bottom, still leave me room for this. These will all get tied together and then connected here, run up the side, come out the hole. Like I said, then I'm going to go solder to a ground right on the chassis versus relying on the ground through the nuts. So let me get all that together and we'll come back. Okay, I got those negatives all soldered together and run up the side in the black wire. So now we can insert this in the can. Just like that. And then we can put this on top once I get the wires all situated on there, and I'll just be bending them down so I can get them over there and feeding them through. So I'll go ahead and do that. I don't need to show you that on camera, but that's the way it's going to be. And then we'll bend these tabs down and it'll be complete. Well, it's like trying to get 10 pounds of potatoes in a 5-pound bag, but there it is. All together. Perfect. All I gotta do is get it back in the radio. Okay, so I got that 6 capacitor block can all wired back in, and all reinstalled and all wired back in. I've got my dropping resistor over there. I think that pretty much completes what I'm going to do on the underside of this for now. Okay, so I got the Cand-ohm resistor all rebuilt. It's not the prettiest girl in the bunch, but I think she's going to get the job done. So if we go across here, I'll show you what I got, and then I'll show you that on the schematic. So right here we have a 400 ohm 5 watt resistor, and then that's going to go into a 6800 ohm 25 watt resistor, which is then going to ground, and then it's tying into a 160 ohm 5 watt resistor that then ties into a 180 ohm 5 watt resistor. And so that completes the entire Cand-ohm. So, assuming I had you aimed at all that stuff. So now let's take a look at the schematic. And if you come over here, there's our 400. That's 6350, and I did a 6800 just because it was close to getting what I needed, and with the right wattage I think that's going to be close enough. This was a 164, I put a 160. This was a 178, and I put a 180. So I think that, considering tolerances back then were probably between 10 and 20%, I think that we should be fine with those numbers. So that's the Cand-ohm resistor. We're knocking down the paths.